What's happening, folks? Geologist Philip Prince. Going to do a gold story today. Don't have one of those on this channel yet. And of course, a mountain with a really little glacier on top is an odd way to start a video about gold. But sure enough, this mountain actually led to the development of what, for a period of time, I think was the largest gold mine on Earth. And this mountain is Puncak Jaya. Sometimes it's called Carson's Pyramid. It's on the island of New Guinea. It's on the Indonesian side of the island of New Guinea. And the reason the glacier is interesting is this thing sits almost on the equator. It's about 4 degrees south latitude. An expedition to climb this mountain in 1936 was what precipitated this really interesting gold find. And summit of the mountains right there. And on that 1936 expedition, a Dutch geologist noted at the end of that arrow on the left that there is an unusual kind of black rock outcropping, almost like a dome of rock coming up out of the ground. Had some green coloration on it, and he thought that that looked like something that might have potential for copper and potentially gold mining. Took a lot of notes about it. Also identified another sort of unusual hill feature in the area that didn't have any trees or vegetation growing on it. Took all this back home, and then World War II came along, and nobody really thought about it much. But post World War II, this potential discovery came to light again, and ultimately ended up being exploited to really exceptional economic benefit. Now, that's where Puncak Jaya sits. That circle right there with the little, you can see like a little lake down inside of it. That's where the first black and green rock outcropping stuck out of the ground. He called that the Ertsberg, which apparently is Dutch for ore mountain or ore hill. And then the larger feature there, the big mine, that again was for a time the biggest gold producer on Earth. That was called the Grasberg or the Grass Mountain. Both of them are now pits now. They have been they have been exploited significantly, to say the least. A lot of material's been removed, but their identification on what at the time, to at least the Western world, if you want to call it that, was an incredibly remote place, was purely a product of Puncak Jaya, the mountain itself. It's extremely rugged, rough, abrupt, prominent, sort of a standout amongst the world's mountains just because of what it looks like, and how rough and barren it is just because it sits right there on the equator. Now, where exactly is all this happening? It's on the island of New Guinea, again, the Indonesian side of New Guinea, which is the northwestern half. Even from this view, you can see there's sort of a spine of mountains that run down the middle of New Guinea, and the equator would be passing through there just to the north of the tip of the yellow arrow there. If you look down the spine of New Guinea, it's a really interesting thing to do from Google Earth. You can see that stretch of mountains running kind of like a backbone. New Guinea sort of looks like a flying bird, I guess, but I mean, it's almost like a living thing with these sort of morphological characteristics, and it very much has this almost kind of like a dragon's back crest of mountains running down it. If you look at it on Google Earth, you can find this mining complex very easily by looking for that big white sort of splash of tailings that have washed out onto the plain below the mountains. That's pointed out by the arrow there, and you just follow that uphill, and that'll take you right to the mine. So this mine has been impactful, to say the least, in many ways, and a lot of folks would say, probably with justification, they have not all been positive. But that's one way to easily figure out where this thing is. It has made a distinct and visible mark on the landscape there, to say the least. And as you zoom in, there's that big splash of tailings again, and you would just sort of follow that river system all the way up into the crest of the mountains there, and that would take you right to the present Grasberg workings up there. Now, the reason that this mountain front is so big and so abrupt is that it is essentially is kind of like a broken slab of the Earth's crust that has been pushed up pushed up out of the earth. It's just sort of one big thrust sheet, one big thrust mass. It's like nine miles thick or something, like 15 kilometers thick. In some respects, you could almost compare it to some of the big mountain ranges in the western U.S., some of the thick-skinned mountain ranges like the Bighorns or the Wind Rivers or something like that. That being said, the style of this structure here is different, and that's something we'll talk about here in just a minute when we sketch this whole thing out in paint to show you what's actually underneath it that produces the mountain and produces the gold occurrence there. When you look at these mining operations, it's just two kind of bullseyes right there, right? They're not strip mining along the length of the mountains. You don't even see evidence of a lot of prospecting or anything else around there. One reason for that, of course, is just exceptionally rugged. It's an alpine landscape. It's like something that you should see at high elevation in southern Europe or something like that. But additionally, the gold is limited. The places that it's been worked on there, and of course it comes along with copper and other metals. It, it's not everywhere. It's just in these kind of select spots. And in fact, the Grasberg pit there, the big one that's circled, mining is done there on the surface now. All of the mining at this site is now underground because the goodies there have sort of been exhausted at this point. I think this thing started running in the early 70s or something like that, and it shut down about 2020, and the mining went underground. Really cool area to explore just logistically. It has this crazy road going up to it, and just to get up there is tough. The rim of the pit there is something like 14,000 feet above sea level, so a little bit over 4,000 meters. If you went there from sea level to that elevation in one day, it would probably be sort of uncomfortable for you until you got used to it. Maybe the highest operating pit mine, or would have been the highest operating pit mine like this on Earth. I don't actually know that. Just building it was a huge challenge, and I think it was an interesting story. I've always heard that the road you're looking at here was not really surveyed. There was a lot of concern about how to build it. Apparently, a guy working up there jumped on a bulldozer and was just like, "I got this," and just sort of started going down the slope and kind of switching back and contouring as he saw fit. And apparently, it worked out. I don't know if that road is exactly as it has always been, but that's a story I've heard in association with this place. If you work in geology, tectonics, you hear a lot about New Guinea, and you hear a lot about the big metals occurrences in New Guinea. This is very much a place that's on the geologic mind, particularly because the island is just so active in terms of plate tectonics. It's very much equal to a Himalayas or something like that in terms of dynamic parts of the Earth's surface. Some of the older Google Earth imagery is really cool. You can see these giant dump trucks coming up out of the pit there. I think the pit was 1,700 feet deep, 550 meters deep, or something like that. It may have been deeper than that, but an absolutely monstrous operation. But this is sort of industrial gold. You have to invest big to earn big off of something like this because the ore that comes out is huge volumes of it, and there's only a tiny amount of gold per the amount of processed ore. So this is a distinct way of extracting gold from going to a creek and panning or something like that. But this is what actually produces significant volumes of it over time. And Puncak Jaya there just sort of looms over this thing. So it's a crazy juxtaposition of an incredible summit with an equatorial glacier, and again, what for a period of time I think was the most productive gold mine on planet Earth. If you climb Puncak Jaya, when you're coming in on your approach to it, you think you're up in this valley right here. You can actually look down and see the lights around the mining operation. So why is there gold here? It happened to be noticed by the right guy in the right place at the right time. The background rock here is this sedimentary rock that has been lifted up to form the crest of the mountains there. Limestone and shale, that is not a rock type that has gold distributed throughout it, really in any case. Incredible to look at in Google Earth, and that's the rock up here. I mean, you can trace these layers, and they're actually kind of bent into folds there. You can trace that for miles and miles along the crest of the ridge. There isn't much change in it, and those gold and copper occurrences, or the rocks that sort of betrayed the presence, were little they were kind of gumdrops or whatever, they stood out because they were geologically different. That's again where the big Grasberg pit was or is, Erzberg there right next to it. So what put these these two kind of localized occurrences of copper and gold that were big enough to go to all this trouble to run these crazy mines up on top of these limestone mountains. So that's one that you're going to need to diagram out here. So we'll hop out to paint, do the block diagram thing, and try to explain all this. And I think you will be amused by where the gold actually comes into play here, because it's going to be a fair amount of work to get there before you actually see it. So hang on just a minute. Okay, so here we are in paint. Going to talk about why there's such a huge mountain range here to begin with. Why it's got limestone on top of it, and also where that gold and copper came from to end up in just those two little concentrations. But first and foremost, this is it's a compressional, a collisional mountain range, and we're going to have to take a section of Earth's crust and make it shorter but much thicker. So we'll draw out our section of crust here to start with. And this is going to be a section of crust that already has a fault in it here. And that fault in the past has kind of dropped one side of the crust down relative to the other one, right? So that's the motion that would have occurred there in the past. And now we're gonna push that thing, and it's actually gonna kind of reactivate that fault. So we're going to push that deep layer up. And how far do we move it? Probably about like that or something. Then we're going to move the layers on top of it even farther. So what we're going to end up with is this big slab, or again, sheet of the Earth's crust that's been kind of pushed up and out relative to what's underneath it. And Australia, would be off to the right of the screen there. Now, was there this gigantic thing sticking up out of the earth like this? Of course not. First of all, rock can't act like that. It would collapse under its own weight. There wasn't something like this, creeping across the land surface either. And one of the reasons here is tropical precipitation over geologic time. This is a really rainy neck of the woods, and rivers fed by that tremendous rainfall are very capable of producing large scale erosion. So here's my tropical thunderstorm kind of looming over this thing and doing all the raining there, right? So that has been happening for literally millions of years and has been sort of limiting the growth of the geologic structures here. So instead of having that big thing sticking up there, the topography has been limited down to, something like that right there. So the amount of structural geologic movement here relative to the actual mountains that you see today is quite different. The amount of rock motion relative to how much mountain expression goes along with it. It's kind of two different ball games. So we'll clean this thing up here a little bit and try to eliminate material that we've pushed away from, eroded away, whatever else. Try to clean that up as quickly as possible with the thick line there. There we go, looking good. So that's going to be sort of our landscape profile there. And then we can kind of let that expand outward here, into sort of this block diagram format. And presumably you can see where this is going to go in terms of the shape of those mountains that we've already looked at. I'm going to take some time here, pretty this thing up some. We're going to add a few colored layers for your reference and everything else. And once we get the stage set there, then the gold is finally going to arrive. So hang on just a minute. We're going to speed this up. Okay, so after all that, I was going to try to do the tailings out there on the basin there, but I gave up on it. So got all that squared away. You can see the overall shape there. It's just a big sequence of rocks kind of flipped up, pushed up along. Big thrust fault here, sort of elegantly simple almost in terms of the overall construction there, in the sense that it's just a big, huge, miles thick slab of the crust that has just been driven up. So where's the gold? Well, there's not any on there yet. The whole story there at Puncak Jaya, here it comes. It's just an igneous intrusion that has and it's quite narrow, small, localized. It might have, kind of some branches coming off of it like that or something. And that has come from a much deeper magma chamber, many, 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 many miles, many kilometers deep down below the surface there. This would have happened about 3 million years ago or something like that. It's generally thought to be about the same age as the big episode of the faulting and uplift here. I have not seen it indicated that the igneous body coming up is chopped off by the fault down there at depth. Doesn't really matter, I don't suppose, but that's where the copper and gold came in. It was actually concentrated from the Earth's mantle into the magma. The material comes up as the magma through sort of the pipe there, and as it gets shallow in the crust and actually starts to cool down and crystallize, it evolves large amounts of what are called hydrothermal fluids. That's where the metals concentrate, and they tend to shoot off into kind of veins and fractures and things like that. Ultimately, right sort of towards the top of the intrusion is where a lot of the metals concentrate. It's called a porphyry type deposit, if you want to read about it. But that's what the mining is doing actually. So let me move the window here and we'll zoom in. So yes, again, all of that geologic structure there just to draw that little black line coming up. But that's sort of the name of the game. And what the mine is doing there, or has been doing, and really continues to do underground, I guess, is just kind of attack the very top of this igneous intrusion here. So that's why the mine is shaped like that, and it just kind of spirals downward, until it gets out of the good material. And you can go over here and maybe do the same thing with this little intrusive arm there. Same type of plan, and run that one until you get out of the good stuff. So the occurrence really is very limited. It's just that localized spot. It didn't really have much to do with the actual limestone layers here into which it's intruded. That being said, the Ertsberg, I think, is classified as called a skarn, Skarn type of deposit. And that is one in which there's sort of a bit of geochemical reaction between what's coming out of the magma body here and the rock that it's being intruded into. When it's a carbonate rock like limestone, that really favors that type of reactive behavior. So big mountains, a lot of rock moving around, just a tiny shot of magma came in there and sort of made all this happen. So it's an interesting way to think about how these things work. And my magma occurrence there is quite exaggerated too. It'd be even smaller than that in real life. So emphasis, right guy, right place, right time. Now, why is there magmatic activity underneath this spot to begin with? It's sort of a collisional setting. There's not subduction going on here like you associate with collisional margins or convergent margins in volcanism elsewhere on Earth. So figured that one out. We're gonna have to do one more drawing here. So we're gonna say goodbye to this one and lay out just sort of a generalized margin of Australia this time around. So another kind of block diagram thing, just at a very different scale. So we'll have New Guinea there, and then we'll have just the very edge of Australia on that side. Like this going on. Try to block this thing out in a good way. Move my window here again. That ain't gonna work. There we go. Okay. So it will be my make it a little bit wider than that. Be my island, New Guinea right there. It's going to look something like this. Australia there, another little bit of Australia right there. And then we'll try to come up with a little bit of subsurface structure here for New Guinea. Complex place, but at the end of the day, it's a bunch of material sort of shingled onto the edge of the Australian continent there. So this would be Australia, and then we have kind of the traces of past subduction left over there. And we'll add the mantle lithosphere there as well. Okay, so see if we can color this thing in here. I'm going to use kind of a funny color for the land on New Guinea because I need green for my mantle. If this is the first one of my videos you watch, my mantle's always green because the Earth's mantle is made predominantly of green minerals. So you're always going to see that here. We're going to lay up some oceanic crust there. We have continental crust for Australia. And we're going to make the Australian landmass a different color here. It's a little bit less tropical rainy than New Guinea is. So that's going to be the edge Australia there. Lay out a few mountains here in New Guinea. Kind of have that big spine of mountains just running the entire length of it. And we'll have a wider belt of mountains down in Papua New Guinea there. So bear with me just a minute, a little more mountain topography here, just so it kind of looks like a different place. And all of this is going to be rising up out of the ocean here. Let's color in some water at this point. Pacific Ocean. I'm going to use a different color there for the cross section there. And there we go. And the Arafura Sea here again is so shallow, it's really not even possible to draw it in a cross section. It's only it's a couple 100 feet deep, 60 meters or so deep, I guess, on average. Would have been dry land in the ice ages. Really interesting body of water in the sense that it sort of floods the actually the edge of a continent there. I'm going to finish off a little block shape there, maybe even throw in a little ocean bottom detail. There is sort of a trench trying to form off the edge of New Guinea underwater there, and some people say that that's actively a subduction zone. I don't really know where the jury stands on that one. All right, finishing up here, something like that. Couple more colors here, and we're going to be all done. Okay, good. So New Guinea, big lime green island there. Got Australia here on the right side, and all of that big gray there is the edge of the Australian continent. Now, why is there magmatic activity going on here? Well, we got to add one more little detail. And these funny little things down here are representing oceanic crust and what would have been lithosphere that was subducted down into the mantle long ago. Now, when that happened, that introduces materials from shallower in the earth down into the mantle and kind of stirs things up and makes for mantle material that tends to be a little bit enriched in metals, copper, gold, things like that, so that when that metal, the mantle can melt a little bit, those metals can shoot up as magma, right? So to get eruption going on here, you've got to get this mantle material moving upward somehow. That takes really hot stuff, takes it to lower pressure. That gets your melting going on. What's going to do that? Well, it's been suggested that just the shape alone of Australia here and the fact that everything you're looking at has let's see, that relative motion there. The edge of this continent is kind of like, it's like plowing the mantle up there. And that would be a way that you can move the rock upward and end up getting some melts forming, and they migrate over here. And that would be where you see eruption has occurred, or emplacement and what potentially would have been eruption at the mining site today. Again, few million years old. So that's one option there. The option that you see, I think, in the literature recorded the most is what's called delamination. So that would involve this whole area here breaking loose and sinking down into the Earth's mantle. So I will do my best to draw that here efficiently. It may be kind of tough to do. So we're gonna green out all of this. Doing all right there. And then we'll actually redraw that block as having sunk down. And kind of the level of complexity that we're talking about here, kind of how it goes. There's quite a bit of tectonic science that goes into understanding metals deposits and what makes them form. And you can find all you ever wanted to read about this if you are inclined to do so. Okay, so there's our block that sank right there. Okay, got that figured out. And what that has done is produce this big kind of void here into which deeper, hotter mantle material can kind of flow and fill in. Again, this is called delamination. And that upward movement, ooh, that's going to give all kinds of nice melts here. Again, that should be past tense, and then they can migrate up and erupt and in place and whatever else. So that's kind of model number two. One way or another, the volcanic history there, the igneous history, it probably would have been volcanic. These materials were in place pretty shallow, and it seems with pretty good confidence there would have been some eruption associated with it. The the igneous rocks are coming out of the mantle. The copper and gold kind of concentrate into the melts from the mantle. That's where they're starting. They make their way up, and as they get shot up into the crust and things cool down, then they get concentrated in those fluids even further. So it's like almost like distillation, various stages of distillation that ultimately take those metals up into the shallow crust and up into the mountains. And if we zoom in here, Puncak Jaya there is going to be this little gray sliver right there. And as you can tell, it is very much a part of continental Australia there. So from the tectonic standpoint, I think you can say for sure that it would be a seven summit because it's part of the Australian continent. And if you Google Grasberg Mine, you will see what has been illustrated here. You will see that written in text, and sometimes you'll actually see it drawn out as conceptual diagrams like this, right? So the journey of metals deposits from the Earth's mantle into magmas into the crust and ultimately getting mined is a pretty complex one. It's pretty interesting. Okay, back to the maps now. Okay, so so that's it. After all of that and all that tectonics and tectonic plates moving around and huge masses of rock and whatever, the actual occurrences themselves are quite localized, and they were little shots of magma of the right overall chemistry that had the right cooling process to concentrate that copper and gold and other metals where they were near the surface and able to be seen and whatever else. So it was quite a bit of coincidence coming together. And talk about right place at the right time, because it's not a widespread occurrence here. If you were looking for traces of this in rivers or something like that, you probably wouldn't see it because there's not the right intrusion in every single river system coming down off the mountains. Quite literally, right place at the right time. There may be more of these. There's another one out this way that's a huge productive gold mine. And it's possible just because of the way the Australian margin acts around here that there are more of them. It's possible to survey for these remotely to some extent just because the nature of the igneous rock is so different from the limestone around it. But suffice it to say, um, uh, just the perfect combination of variables came together to make this place happen. So when you look at that margin of Australia, you want to think about New Guinea being kind of stuffed up against it there. And sure enough, the very edge, I guess, kind of the southwestern edge of the mountain range here is unequivocally a piece of a sliver, if you want to call it, of the Australian continental margin there that got pushed up. So Puncak Jaya and this gold is it's on Australia from the plate tectonic standpoint. Really interesting area. And if you look at all of the nature of the ocean bottom around here and all these islands, some incredibly complex tectonic geology going on around here. One of the coolest things about this mine, though, because it's up on top of the mountain, is they don't drive the ore out of there. They actually pipe it. It gets crushed up, processed a little bit. The copper and gold ores are concentrated, and they come off the mountain actually through a pipeline with kind of this mud, if you will, passing down through it. Um, People have not been pleased with the presence of this mine in the past. It has been essentially attacked, I think, a few times. And one time that it happened, the pipeline actually got blown up, so it sort of shut down shut down transmission of the actual pay dirt there for a period of time. But that slurry gets down to the coast there, and they have a shipping port that you can look at on Google Earth where the material comes out, gets dried, it may get processed more here, and it ends up on ships and goes to wherever people are buying it. So it's a really fascinating place just in terms of the occurrence of the copper and gold, the fact that a guy was climbing up there and just happened to pick out something of interest, and what it's taken to develop this thing and actually get the materials off one of Earth's most incredible mountain ranges down here to the coastline. So when you're looking at this range, again, it looks like something in the European Alps with this bare gray limestone up on top of a mountain peak there. Looks like it's kind of a pristine setting, arguably, and to me, definitely one of the Earth's seven summits right here. But just a few miles away, a few kilometers away, you had this incredible mine pit going on. It's a crazy, crazy juxtaposition. But the plate tectonics that makes mountains like this is also the plate tectonics that ends up moving the materials around that allow you to concentrate those gold and copper ores in such a way that it's worth going up there to mine them at the large scale. So cool place, and certainly one to check out on Google Earth, particularly if you cycle through the years of imagery. You can watch the little glacier up here change. There's not much left of it actually at this point, 2023 or 2024. Hope you enjoyed this video. Going to be back stateside for the next one, and hope you check that one out too.